Welcome back to the podcast, definitely. Today, we're going deep, diving deep into this really interesting area where AI and the quest for, living longer kind of come together. So we're going to be talking about this experimental AI model. It's designed to speed up research on something called Yamanaka factors. And these proteins, they can actually reprogram adult cells into stem cells. So just imagine turning back the clock on your cells right. This could mean custom-made organs, revolutionary cell replacement therapies. So if you're at all curious about regenerative medicine, the future of it, and how AI could help us all live longer, healthier lives, you're in the right place. And if you like what you hear today, don't forget to subscribe to our YouTube channel and like the video. All right, let's get into it.
Yeah, these Yamanaka factors are pretty amazing. I mean, they could totally change how we treat diseases and even aging itself.
It does sound pretty sci-fi. Can you
Yeah.
break down exactly what Yamanaka factors are and why they're so important?
Okay, so think of it this way. You've got skin cells, muscle cells, brain cells, all these specialized cells that do specific jobs in your body. But they all started as stem cells, right? These blank slate cells that could become any type of cell. Yamanaka factors can rewind that process, basically turning adult cells back into those stem cells.
So you're saying we can take a cell that's already like a skin cell
Yeah.
and make it able to become, say, a heart cell or a nerve cell.
Exactly. And that opens up some incredible possibilities for regenerative medicine. I mean, imagine growing a new heart from a patient's own cells. No need for organ donors, no risk of rejection, or think about repairing damaged brain tissue in Parkinson's patients by replacing those lost cells.
That's amazing, but I'm sure there are challenges in making this work in real life.
Oh, there are. Traditionally, reprogramming cells has been kind of like winning the lottery.
Right.
The success rates are low and it can be a really slow process.
So where does this experimental AI model fit into all of this?
That's where things get really interesting. This AI model is still in its early stages, but it's designed to optimize these Yamanaka factors. To make that reprogramming process much more efficient, it basically analyzes the structure of these proteins and suggests modifications that could make them better at reprogramming.
So the AI is like a master editor fine-tuning these proteins to make them more effective.
You could say that. It's similar to how those natural language processing models analyze and rewrite sentences. But instead of words, this AI works with amino acids, the building blocks of proteins.
So it's going in and rearranging those amino acids to make the Yamanaka factors better at their job.
Precisely. And the early results are really promising. In some tests, the AI has made 2 Yamanaka factors over 50 times more efficient.
Wow, that's incredible. But I'm guessing it's still early days.
Oh, absolutely. We need to be cautiously optimistic. These results need to be, validated and replicated by other scientists, but the potential is definitely there.
So we could be talking about a future where we can reprogram cells way faster and with a much higher success rate. What could that mean for medicine?
Well, for starters, it could drastically reduce wait times for organ transplants.
That would be life-changing for so many people.
And it's not just transplants. Imagine being able to repair damaged heart tissue after a heart attack, or regenerate insulin-producing cells in people with diabetes. The possibilities are really huge.
It sounds like this technology could completely change how we approach healthcare.
It very well could. And like any groundbreaking scientific advancement, it raises some important ethical questions. Questions we'll need to address as this technology develops.
That's a great point. Before we get into those ethical considerations, I want to understand a bit more about how this AI model actually works. You mentioned it analyzes protein structures. Can you explain that in a way that someone who's not a scientist can understand?
Sure. Imagine a protein, like a chain of Lego bricks. Each brick is an amino acid. The order and arrangement of these bricks determine the protein's shape and function. So what this AI does is analyze the arrangement of these bricks and suggest ways to rearrange them to create a more effective structure.
So it's like the AI is finding the best Lego configuration for each job.
Exactly. And what's really fascinating is that Yamanaka factors are naturally disordered proteins, meaning their structure is more flexible than other proteins. This flexibility makes them perfect for this kind of AI-driven optimization.
That makes sense. So the AI is using that flexibility to find the most effective arrangements for these proteins.
That's right. The AI can explore way more possibilities than traditional lab experiments, which usually involve changing just one amino acid at a time.
So it's like the AI is running thousands or even millions of virtual experiments to find the best protein design.
That's a good way to think about it. And the speed is amazing. It can analyze and redesign proteins much faster than using conventional methods.
It sounds like this AI could be a game changer for all kinds of scientific research, not just cell reprogramming.
Absolutely. It could speed up drug discovery, create new materials, even lead to breakthroughs in things like biofuels and environmental remediation.
So we're really talking about a whole new way of doing scientific research.
Precisely. AI is becoming a really powerful tool for scientists, allowing us to tackle complex problems that were impossible before.
Now, you mentioned earlier that this technology raises some ethical questions. Could you elaborate on that?
Sure. Like any powerful technology, there's always the potential for misuse. We need to think carefully about what it means to manipulate the very building blocks of life.
What are some specific concerns that people have brought up?
Well, one concern is that it could worsen existing inequalities. If these therapies are expensive, will only the wealthy be able to afford them? How do we make sure everyone has access to these potentially life-changing treatments?
That's a valid point. We've seen similar issues with other advanced medical technologies.
Yeah, and another concern is the potential for unintended consequences. We're still learning about the long-term effects of cell reprogramming. What if there are risks we haven't even thought of?
So it's important to be cautious and not get ahead of ourselves.
Exactly. We need to balance the excitement about the potential benefits with a healthy dose of skepticism and a commitment to rigorous safety testing.
And it's not just about the science, is it? We also need to have open and honest conversations about the societal and philosophical implications of this technology.
Absolutely. What does it mean to extend human lifespan significantly? How will it change our relationships, our careers, our sense of purpose? These are questions we need to address as a society.
It sounds like this technology is making us rethink some fundamental questions about what it means to be human.
It is. It challenges us to think about the future we want to create and the values that will guide us.
We've covered a lot today, but before we wrap up, I'm curious to hear your thoughts on what's next for this technology. What are some of the key milestones or breakthroughs we should be looking for?
Well, the first step is replicating and validating the initial findings in different labs. It's crucial to make sure these promising results hold up under scrutiny.
So peer review and independent verification are essential.
Exactly. Once we have that confirmation, the next step is preclinical trials, testing these modified Yamanaka factors in animals.
And if those trials are successful, then we can start thinking about human trials.
Right. Human trials will be crucial for assessing both the safety and effectiveness of these therapies in people. And that process can take several years or even longer.
So while the potential is huge, we need to be realistic about the timeline. It's going to take a while before these therapies are widely available.
Yeah, it's important to manage expectations. Scientific progress rarely moves in a straight line. There will be setbacks and challenges along the way.
But even if it takes time, the possibility of regenerating organs and reversing the effects of aging is incredibly exciting.
It is, and it really speaks to the power of human ingenuity and our desire to learn and discover.
It's been a fascinating conversation. Thanks for sharing your insights. This is clearly a field with huge potential for medical breakthroughs and for making us think deeply about the future we want to create.
It's been a pleasure discussing this with you. I think it's important to have these conversations and get the public involved in thinking about the implications of these advancements.
Well said. And that's what we've tried to do today on Le Podcast de Philippe. To our listeners, we hope this deep dive has given you a glimpse into the incredible possibilities of AI-powered cell reprogramming and the questions it raises about the future of humanity. If you enjoyed this episode, don't forget to subscribe to our YouTube channel and like the video. We'll be back soon with another deep dive into a cutting-edge topic. Thanks for listening.
That's right. The AI can explore so many more possibilities than we could in a lab, Traditionally, we'd change like one amino acid at a time.
So it's like having thousands, maybe millions of virtual experiments going on at once.
Exactly, and the speed is just incredible. It can analyze and redesign these proteins way faster than we could ever do it in the lab.
So this AI could really change the game for scientific research in general, not just for the cell reprogramming.
Oh, absolutely. It has the potential to really speed up drug discovery, maybe even create entirely new materials. And it could lead to breakthroughs in things like biofuels, even cleaning up the environment.
So we're talking about a fundamental shift in how we do science.
Exactly. AI is becoming such a powerful tool. It's allowing us to tackle problems that we could only dream of solving before.
Now, you mentioned earlier that this technology raises some ethical questions. Could you talk a little bit more about that?
Of course, like with any powerful technology, there's always the risk of misuse. We have to be very careful when we're talking about manipulating the building blocks of life.
What are some specific concerns that people have?
Well, one big concern is that it could make existing inequalities even worse. Imagine if these therapies are super expensive. Only the wealthy would be able to afford them. So how do we ensure that everyone has access to these treatments that could be life-changing?
Yeah, that's a really important point. We've seen this happen with other advanced medical technologies.
Right. And another concern is that there could be unintended consequences. We don't fully understand the long-term effects of cell reprogramming. What if there are risks that we haven't even considered yet?
So we need to be cautious and really think things through.
Exactly. We need to balance the excitement about the potential benefits with a healthy dose of skepticism. And of course, rigorous safety testing is absolutely essential.
It's not just about the science either, right? We need to have open and honest conversations about the social and philosophical implications of this technology.
Absolutely. What does it even mean to extend human lifespan by a significant amount? How will it change our relationships, our careers, our sense of purpose? These are really big questions that we need to grapple with as a society.
It seems like this technology is forcing us to re-examine some fundamental questions about what it means to be human.
You could say that it's a challenge to think about the kind of future we want and the values that will guide us as we move forward.
We've covered a lot of ground today. But before we wrap up, I'm curious to hear your thoughts on what the next few years hold for this technology. What are some key milestones or breakthroughs that we should be watching for?
Well, the first big hurdle is to see if other labs can replicate these initial findings, make sure they hold up.
So peer review and independent verification, that's going to be key.
Exactly. Once we have that, then we can start thinking about preclinical trials, testing these modified Yamanaka factors in animals.
And if those go well, then we can move on to human trials.
Right. Human trials are going to be absolutely crucial. We'll need to see how safe and effective these therapies are in people. And that whole process can take years, maybe even longer.
So even though there's so much potential, it's important to be realistic about the timeline. It's going to be a while before these therapies are widely available.
Yeah, managing expectations is important. Scientific progress, it's not always a straight line. There will be setbacks and challenges along the way.
But even if it takes time, the idea that we could regenerate organs and reverse aging, that's incredibly exciting.
It is, and it really shows you the power of human ingenuity, our drive to explore and understand the world.
This has been a fascinating conversation. I really appreciate you taking the time to share your insights. This is clearly a field with huge potential, not just for medical breakthroughs, but for making us think about the future we want to build.
It's been my pleasure. I think it's so important to have these conversations and to get the public thinking about what these kinds of advancements really mean.
Absolutely. And that's what we've tried to do today on Le Podcast de Philippe. To our listeners, we hope this deep dive has given you a glimpse into the amazing possibilities of this AI-powered cell reprogramming and the questions it raises about the future of humanity. If you enjoyed this episode, please subscribe to our YouTube channel and like the video. We'll be back soon with another deep dive into a cutting-edge topic. Thanks for listening.